So before we get into this video, I'm gonna give you a warning. This video features a device which works with high voltage, which can cause fatal injuries, up to 6 kilovolts, and there is enough current to even stop your heart. Do not replicate or build the device featured in this video. This is not a DIY project. This video does not contain instructions nor the schematics to build this device. It does not endorse building this device, and also, if you somehow manage to figure out the circuit, if you suck the circuit out of your finger in order to convert 3 volts to the voltage that's used to pop the capacitor, I'm not responsible for any injuries. I'm just showing off my project. This is not a video which is meant to be a DIY project. If you picture this as a DIY project, well then sorry, there are no instructions and no schematics. Just the theory of operation. So yeah, do not build it yourself. This is literally something you shouldn't play with. But anyways, let's get into the video.
Scheiße!
Hello, welcome guys to Sonic the Hedgehog, and I gotta admit, I'm a pretty heavy sleeper, you know? Like, when I don't get enough sleep, I'm aggravated, because I have autism and Asperger's syndrome, I'm aggravated, I'm not nice to people, you know, and problem with me being that I'm going to an electronics engineering school and I have to wake up at 6 a.m. or 6 o'clock in the morning, because I have to drive through here, and you know, the infrastructure here in the Czech Republic, especially where I live, isn't that exactly great. I mean, new roads are being built, which is nice, but with now the new government, everything is going down the drain again. But let's not get into politics. I have a problem. When I wake up, I sometimes, you know, get up easily, or sometimes it's even harder, but most of the time now, especially, it's winter is beginning, it's getting properly cold, and I'm starting to have the big issue where I wake up and I just feel like I'm super glued to the bed. I cannot get up. Sometimes I can overcome that force and get up, or sometimes I just fall asleep again. And then my mom has to wake me up, because the normal alarm clock doesn't wake me up. But I think I have the perfect solution for this, and it's this thing. You might be thinking, what is this? Just a normal alarm clock? It's not even an alarm clock, it's a timer. Well, it's an old Czechoslovakian timer. Well, let me tell you that this thing is very special in the term that it solves both the issues of me not waking up and not getting out of bed. When this thing goes off, it wakes me up immediately and I fly out of the bed. Boom! Both issues solved, except it gets kind of expensive. But this thing, how it wakes you up? Simple. It explodes capacitors, and if you remember, Electro Boom, who I'm gonna tag on this video because I kind of want him to see this. This thing, he built an alarm clock where he used 120 volts AC and a revolving magazine, and that magazine just connected capacitors across 120 volts AC, and it worked. And it looked a bit, you know, it was a bit of a mess. It definitely wasn't a product that you could, you know, take on everywhere with you. And I had the same idea of just connecting up capacitors straight across 240 volts AC, but I wanted the clock to be battery powered. So I built one which is battery powered and rechargeable. And how this works is, you set the alarm on here, which I will explain later once we get onto the bench. Then once you set the alarm, you load it up with the capacitor, and when it's charged, you can just go to sleep, and when you wake up, it will go off. Now, if you look at the back, it's charged directly from the mains, and it's got a nickel metal hydride battery in which takes ages for it to charge, and then it explodes once, and the battery is completely depleted. But you might be thinking, well, why didn't you use a lithium polymer battery? Well, the problem being that I don't want any kind of lithium batteries in this, because high voltage circuitry, and yeah, there's very high voltage in this. The capacitor, there's 2 high voltages in this, I'll explain that later. Plus, this is literally designed to explode stuff, so it's not really smart to have a lithium polymer battery or lithium ion battery in there, is it? So yeah, how this thing works is, it's charged from the mains, 230 volts AC, 50 hertz here, because I'm in the European Union, Czech Republic. And on the back here, there are 3 output connections. There's 2 which output the high voltage. One sends 350 volts down one side of the capacitor, and the other one sends over 6 kilovolts down the other side of the capacitor. And that causes it to detonate immediately. From battery power, from a 3 volt nickel metal hydride button cell, it detonates immediately. Absolutely no delays. And there's quite a complex system which does it. There's a 6-volt power supply which converts the 3 volts to 6 volts to power the relay and the high voltage power supply. And then the high voltage power supply charges a capacitor. That capacitor is then discharged through a couple of small xenon trigger transformers and then out and into the capacitor. And there's also a third pin, and that's used for sensing if the capacitor is there. That detects continuity. If the capacitor is there, if there's a capacitor, there's continuity between the sense pin and the 350 volt pin, and it will activate the high voltage power supply. However, if there's no capacitor, there's no continuity, and it will not activate the high voltage power supply. It's just a safety thing, so that way if someone set it up, then they put a capacitor in it when they woke up and when they touched it, they wouldn't get a shock. Because trust me, this has enough power to stop your heart. And there's one caveat about this. I'm not going to show you any schematics. Nothing like that. I'm just going to tell you a very simplified theory of operation and what's on the inside. Because if you've heard lately, YouTube's stupid AI moderation, I'm even afraid to say that, is, terminating channels. Yeah, they're terminating channels. There's like over 10 million channels have been terminated over like the last half year here. And I'm terrified to lose my channel, and because this thing is properly dangerous, I'm not gonna show you the schematics. As you heard, there was a warning on the beginning of this video. This is not a DIY project. This is not a guide how to build this. This is just showing you my project. I'm not gonna give you any schematics, nothing like that. Even if ElectroBoom himself under this video asks, give me the schematics, I'm not gonna give it to him. Because I'm just deadly terrified to lose my channel. And I know my channel is tiny, I don't even 500 subs. There's channels which have like 100 million subs, but I'm still terrified to lose this channel because it took a lot of work to get this channel to this point. And it also takes a ton of work to make videos. And I just want to stay on YouTube. I've already lost my Instagram account twice, and it's a terrible thing to go through. And if I lose my YouTube channel forever, I just have no really good place to share my projects. So, yeah. So this is just a little cautious thing. So yeah, no schematics, nothing whatsoever. I'm not going to show you anything that would remotely tell you how to build this. Well, I'm just going to see one thing. It's pretty similar to, it's pretty similar to a camera flash circuit what's inside. But that's all I'm going to tell you, okay? So now though, all the rambling over, let's get over to the table and let me show what's on the inside. Also, the system in here, which even is designed to activate and deactivate the explosion circuitry or the high voltage circuitry, is really complicated. It is really complicated. It uses a micro switch. It uses a clock motor to detect on which position the clock dial is. It's pretty complicated, but there is no microcontrollers. It's all transistors, except for the clock IC. It's all transistors. There's not a single microcontroller in here, not a single bit of code in this thing. But that's it. That's all I'm going to tell you about this. So now let's get down to the bench and let's see what's on the inside, how it works. And then on the end of the video, I might show you how it works. I'm going to try and see, because I have one Czech video of it, which I was speaking in Czech. So I'm going to put translation. I've already tried to film videos for this to show you how it works. But the problem was every single capacitor I tried didn't explode. The only video on which the capacitor got remotely close to exploding was a video which I was filming for one of my friends, which I was speaking in Czech. So that's the video I'm going to put after on the end of this video to show how it works. I'm going to put subtitles down there to show you in direct translation as to what's going on. But it was the only video in which the capacitor remotely exploded. It just ended up a whiff of smoke. That's all it did. But trust me, I'm not lying to you. This thing really is spicy. When you've got the right kind of capacitor, which I ran out of, I'm going to have to pop down to the nearest electronics parts store and get a new capacitor. And get some new capacitors. Because if you get the right capacitors into this, which are 10 microfarads at 16 volts, trust me, this thing really does go off. It really is very spicy. It's very violent. It's much louder than if you pop it on mains voltage. That's all I'm going to tell you. And also, one fun fact, this is a hodgepodge of different parts. The newest part, most of the parts here are from the 1980s. There's no modern electronic parts in this, so it's going to be interesting for you to see. But now, let's stop rambling, and let's get down to the bench, and let me show you how it works. Okay, so welcome to the bench, and let's have a look at as I call it, the InstaWakeUp, or the Capacitor-BOOMER Alarm Clock MK2, battery-powered, much higher voltage. So let me give you a quick look around it. So the base for it is an old Czechoslovakian Meopta timer clock, a DIN rail-mounted timer clock. And it's from the 1980s, and what I've done with it is I gutted it, I've reused the circuitry from it, and then just put all the components inside of it. And I had to make a cardboard case for it momentarily because the original case, of course, didn't fit. I've tried to, but Doesn't fit anymore. So how you use this is simple. This over here shows your time, and you just turn it like this, you know, to set the correct time. So let's set the correct time, which is 17:15 almost. So that's 3:15 p.m. for those American. No, that's 5:15 p.m. for those Americans. And we're gonna set it to that. Now, how do you set the alarm on this? It's pretty simple. You have little tangs, which I have elsewhere, which you clip on the outside to the hour which you want the alarm to be actuated on. It's a bit misaligned. Hey, it's not exactly accurate because I had to take apart the mechanism and it got misaligned. I didn't care about it. I didn't put it back together. It's not impossible to take it back apart because it's glued together with hot glue. But you clip the tang on where you want to set the alarm. Can be only set in 15-minute increments. So you can have it either, for example, at straight 10 o'clock, 10:15, 10:30, 10:45, or 11. That's all you can do. You can only do in increments of 15 minutes. So it's not exactly accurate, but if you set the alarm, you, for example, set it to, I don't know, 12:15, you clip it on there, and then you wait for it to turn around, and once it turns around, it actuates this little thing right here, and it triggers the alarm, and it explodes the capacitor immediately. So that's all you can see on it. Now, how is this charged? Simple. On the back here, you've got 5 connections. As I showed you in the intro, 3 of these are for the capacitor. This one right here, 2 of these, one of them does 350 volts, the other one does the 6 kilovolts, or 350 volts down one side of the capacitor and 6 kilovolts down the other, making it detonating it immediately. And then there's also the sense terminal. As I said, that's just safety. If it detects that there's no continuity across, it means there's no capacitor and it will not trigger. Then these 2 terminals right here are live and neutral. And those are the charging terminals because it charges directly off the mains with a simple resistive dropper. And as I said, it's got a nickel metal hydride battery in it, which doesn't last much time and it charges for ages because it just trickle charges, of course. But it's charged directly from the mains, 230 volts AC, 50 hertz in case of here in Europe. Czech Republic exactly is where I am. But now though, let's pop this apart. So, this is what's on the inside. It looks like the B board, does it? I'm sure it does. I'm pretty cautious on saying what I'm saying because YouTube loves us, doesn't it? So, you can see there's 2 floors on this. So down here you can see by this coil and by this other coil I added on, I'll explain that later, there is the clock movement, the clock mechanism down in here, and you can maybe see some of the gears down there. Yes, you can. That's the clock movement down there. This PCB, this perf board right here, that's the clock circuitry from the original PCB, and I just built it onto a smaller perf board to save on space. This over here is the terminals. And on the top are the 2 main PCBs. This over here is the power supply PCB with the relay, generates 6 volts for the circuitry. Over here is the high voltage power supply. Over here is the reservoir capacitor for blowing up the smaller capacitor on the output. Then we've got the battery over here. The micro switch which triggers the alarm is hidden down in there. Then down on this side, as I said, is the coil for driving the clock movement. Then over here we've got another coil recycled from a cheap alarm clock from the nearest Asian outlet. And that's being used as a sensor. I'll explain that later. Because it's got a permanent magnet and it induces a magnetic field in this coil which generates pulses of electricity. Then down here is a little tiny little circuit board, and you can see one of the ceramic capacitors on the board just bent below the coil. That's the circuitry which works with this coil which acts as a sensor. Again, I'll explain that later. Let me show you what we have. So on the bottom here are the mains input connections. You've got live and neutral. So brown for the live, blue for the neutral, as per our local color code. Go to this PCB. For charging the battery, we've got a resistor, which drops the voltage. We've got a diode over here, which rectifies the voltage. Then we've got, so it's a full bridge rectifier because it's a full bridge rectifier. Not full, but full because it's single diode. It's a half bridge rectifier essentially, because that's all I could fit in here. And it's the exact same circuitry which was in the original clock, except for some components removed because they weren't really important. And then we've got a Zener diode across the battery to clamp the voltage. As simple as that. Then there's just a simple little transistor circuit which cuts off the charging which disconnects the voltage from the battery when the battery is fully charged. Seriously, it's so simple. When the battery reaches a specific voltage, it triggers the transistor. I just completely forgot, but I know it's very simple. When the battery reaches a specific voltage, the transistor disables and it stops charging the battery. Over here, we've got a cheap no cheap. We've got an old Czechoslovakian IC, which was in originally, and what's even which is what's more the most amazing thing about Czechoslovakian appliances is back when we were Czechoslovakia, now we split up into the Czech Republic and the Slovakian Republic. Funny stuff was that the old communist engineers, turn off the soldering iron. The old communist engineers they'll get like an inquiry to say, or basically a sort of command from higher up communist leaders saying, a company will come and say, hey, make a timer clock. And that's it. You had a strict deadline, and because it was communist era, you only had what was being made. So some of the devices were literally a hodgepodge of various different components that they could just get to get it working. And what they have in here is not the standard clock IC, it's a alarm clock IC, meaning you can wire the micro switch down here to it, and it will just output an alarm signal. Beautiful. And when you disconnect the voltage from it, it will reset and it will stop outputting the alarm signal. Isn't that amazing? I think it is. Then up there is the tiny little crystal. I'm going to show you the crystal. Right up in there is the tiny little clock crystal. I can't exactly remember the value. It's 32 point something megahertz or kilohertz. Right there is the resonance capacitor for it, or resonance capacitor for it. Which goes in series with it, of course. You have to use a capacitor in conjunction with a crystal for reasons. Next, so that's the clock part, and then that's just connected directly across this coil. Other inputs going into the clock circuit is this micro switch, and then you've got outputs which go up to this power PCB. The power supply PCB is pretty simple. It consists of a relay, and that relay switches the power to the high voltage power supply. You've got an inductor and a simple Royer oscillator, creating a very simple DC to DC converter, which takes the 2 point something volts from the battery and converts it to 6 volts for the relay plus the circuitry. Yeah, it's very simple. It actually gives us spot on 6 volts, which is kind of surprising. Now, it's actually not a Royer oscillator. What am I talking about? It's an astable multivibrator, but a very chopped down simple one. And again, components in this are really old. There is no modern components in this, absolutely none. Except for that inductor. Everything is basically old stock, except for that thing and that inductor right there. So, yeah. Next, you've got a transistor over here, which is responsible for turning on the relay, and there's also a diode hidden down there to act as it's a flyback diode on that, so that it doesn't kill the transistor when the magnetic field collapses. These two wires over here are the battery wires. These wires over here go from the sensor PCB, I'll explain that later. And then how the battery is charged is voltage comes in, and the charging voltage for the battery is taken directly from the clock PCB and onto here, and it just connects directly to the battery. The battery connects onto here and it powers the 6-volt power supply, which, when shorted out, stops outputting voltage. That's one part how this cuts off, we'll explain that later. And then there's just a bunch of resistors and a ceramic capacitor. Then over here is the main reservoir capacitor for the high voltage circuitry, which does the boom, and then over here, well, that's not the capacitor which explodes. The capacitor which explodes is external. This capacitor is just used as the power reservoir. And if you notice, look at these beautiful spiral connections. How you do these is, you take a small drill, you wind copper wire across it, and then you put it onto the capacitor leg, and you put the wire into it, and then you just put a ton of solder into it, and makes this really nice connection. I got that, they taught me that they taught me that in electronics school, which I'm going to, and it's a pretty neat little trick. But let's have a look at this. So what you have on here, the main part is a semi-high voltage transformer which charges this capacitor. You've got a controlled spark gap, which is used as the output switching device. You've got the switching MOSFET for the transformer. You've got the switching triac. Oh, they are both triacs. You've got the switching triac for the controlled spark gap. You've got 3 xenon trigger transformers wired in differing orders. And you've got a simple oscillator circuit and some current limiting resistors on the top here, nice wire wound ones. And you've got also an output high voltage capacitor. So, how does the high voltage circuit work? Well, first of all, let's explain the whole sequence of operation. So the clock circuit is running, and it's pulsing, or quickly pulsing this coil, which is turning the clock around. Once the clock hits the set alarm value, it'll trigger via these cantilevers back here. It will trigger the micro switch, and after the micro switch will short out 2 pins of the IC, and the IC will start sending out an alarm signal, or that's just a continuous voltage, pulsing voltage for the beeper. it sends that out to this PCB. That pulsing voltage, oh, and it's not a pulsing voltage, I forgot, it's a continuous pulse, because these ICs, this specific type of IC has an external buzzer driver. The buzzer has its own driver, so it just sends out a voltage, and that voltage triggers this transistor, and that turns on the relay. Now, the high voltage circuit has got 3 wires going into it. The red is always providing 6 volts to it to charge up this capacitor. The black is the ground, and then the blue is the explosion wire. So this relay triggers, it sends 6 volts down this wire. What starts happening here is, well, first of all, when there is no alarm and it gets turned on, the oscillator circuit on here activates. It charges up the main high voltage capacitor, 10 microfarads at 350 volts. Then, once this relay triggers when the alarm is due, it will activate the explosion circuit. A series of things happen. It activates the, what happens is the charged up capacitor, by this circuitry, is discharged to a couple of systems. The 6 kilovolt line is done by this yellow wire, which goes down the 6 kilovolt step-up transformer. That transformer then goes under the circuit board, goes to the controlled spark gap. Then the voltage can't go anywhere because there's no arc physically. There's no spark across this, so the voltage can't output. By the way, the voltage can output through the yellow wire. And first of all, that voltage gets sent down there. Well, if there is the green wire right here detects if there is a capacitor present, and if there isn't a capacitor present, the circuitry will not even turn on. But once the alarm is due, the microswitch will be triggered, the clock IC sends out a pulse, it turns on this transistor that latches on the relay, sends 6 volts down the blue wire. That triggers the explosion chain of the circuitry. One side of the capacitor, as I said, the yellow wire goes through the 6 kilovolt transformer, winds up at the spark gap. However, the circuitry designed for actually doing the spark gap is pretty simple. Or actually pretty complex, shall I say. Well, I'll explain how that works. So the green wire does the spark gap plus the 350 volts. So the green wire goes down here, goes onto this branch point. It splits off into 2 ways. It goes through this current limiting resistor and winds up in the purple wire, which is the 350 volts feed out to the other side of the capacitor. So 6 kilovolts for the yellow wire on one side, 350 volts for the purple wire on the other side, and green is just the sensing, which is connected, which actually on the capacitor is connected to the same point as the 350 volts. So it goes through this current limiting resistor and winds up at the upper current limiting, so that way it literally doesn't kill you, or it doesn't create such an explosion that it actually is dangerous. It is still dangerous. So half of the power goes for another current limiting resistor and goes down this high voltage transformer where it gets stepped down. It goes to this transistor circuit, and that's a circuit used to detect if the pulse has been fired. But then it goes to here, and this transformer again steps up the voltage for the spark gap, and it goes through these resistors. Then it goes to the grid of the spark gap right here. This over here is the triac, which actually switches the high voltage, like the 600 volts, to the controlled spark gap to trigger it. So once this MOSFET is fired, or this triac is basically, once the triac is activated by the circuitry here, it will send 600 volts down the control grid of this controlled spark gap. And what happens there is, when a high voltage is induced in this grill, it will ionize the gas inside and will cause the high voltage to spark over these electrodes, and it will output the 6 kilovolts out. So what happens here is, alarm is triggered, and at the same time, two things happen at the same time. A couple of things happen at the same time. High voltage, 6 kilovolts is generated by this yellow wire going through the step-up transformer and winds up at the spark gap. But at the same time as that happens, this triac is triggered, and it sends the 600 volts down this controlled spark gap. And once that happens, it effectively, because the capacitor is not connected anywhere, it has 350 volts on one side, but it doesn't do anything, since it doesn't have a pulse path back to the circuit. However, once this control spark gap is triggered, these 6 kilovolts will jump across these electrodes, go into the capacitor, and once the 350 volts and the 6 kilovolts go against each other, the capacitor detonates instantly. After that, though, we've got a problem, because the high voltage circuitry is running. And because the capacitor is often shorted across, we will get 350 volts on the sense pin, which means the capacitor is there, and it will not cut off. But you got a problem, because this is a timer clock. the load, the high voltage power supply being triggered by this micro switch will run. Oh, it will continue to run at least for 15 minutes, and that will be a problem. You guess why? Simple. It just, after only this thing for running continuously for 5 minutes, it'll get extremely hot. And like after 15 minutes, it could get to the point of the transformer burning out. And that is an issue. And I, of course, could design another mechanism, which right after it exploded would trigger another micro switch, would disable it, but, well, let's just ignore that. But we have to have a circuit which disables the whole thing so that the transformer doesn't burn out. That's what this thing does. This is being used as a sensor, and when the gear in here, which holds the magnet, revolves, it generates a pulse in this coil. And this gearing in here is so brilliant that I could just tap onto it, and just a second after the alarm was triggered and the capacitor would be already exploded by then, it would output a pulse on the electromagnet. And that's great news, because we can use that to cut off the high voltage circuitry. So there's a simple 3 transistor circuit down here, that's the little circuit board we see down here. It's designed to convert the little pulse of voltage into a switch, basically into a direct short. So a second after the capacitor has exploded, the gears in here will revolve enough that the magnet in here snappily revolves. It will induce the spike of voltage in here, which will get into the circuitry. This circuitry also has power, by the way. It will convert that into a switch, and it will short across these two positions on the high voltage power supply. What that will cause is it will completely short out the oscillator on the high voltage power supply, plus it will short out the 6-volt power supply, meaning all of it will lose power completely. And you know how the clock IC works? Simple, the clock IC completely resets when you lose power, meaning it completely disables the alarm. So the circuitry, it shorts out the power. The 6-volt power supply goes down to 0 because it doesn't have enough current to cope with that. And, oh, it is shorted, so no power supply would have enough current to cope with that to generate any voltage. So, once that short happens, the circuitry will be completely unpowered for just a millisecond. That will be enough for the clock chip to reset, to stop outputting the trigger signal to the transistor which drives the relay. Then after that will happen, everything will reset, the relay will be disabled, the high voltage power supply will be disabled, and we're back in normal operation just as a clock. How genius is that? And you don't want to hear the even funnier thing about this? Do you think there's a microcontroller in here? No, there's not. Everything is done by transistors. Everything is done by really ingenious transistor circuits. That's it. This really shows you can do a pretty complex device. It's just a pretty complex task. You know, you can do that without microcontrollers. And what's even more amazing about this is it takes 3 volts and it steps it up to 6 kilovolts. What can I tell you? I mean, the circuitry is kind of borrowed from camera flashes. It's basically a couple camera flash. It's a camera flash circuit, basically, that's slightly modified. It just works excellently. There's no issues with it. It works. And it does it flawlessly. And it fixes the 2 biggest problems. Because I gotta admit, I'm a pretty heavy sleeper, and I have 2 problems. When something wakes me up, I usually have the problem that I feel like I'm super glued to the bed, and I cannot wake up, and then I just fall asleep immediately. This thing solves both of them. It wakes me up and also gets me out of bed because I ran away from it just from being scared. How good is that? So yeah, now though, let's put it back together and let me show you the test.
Okay, so as you can see on the background, it's sticking right now. It's running, the battery is fully charged. It's set to wake us up like in under a minute. As you can hear from my voice, I'm pretty terrified. I'm shaking because this is pretty terrifying and the suspense is killing me. So let's see what it does. It should go off right now. I heard the relay click. Oh, this didn't work out as it should. Something did happen, but yeah, it should have blown up way better than this.
Tak to vůbec nebouchlo. To ten kondenzátor.
Okay, so just a little reminder I want to tell you here. As you've seen in this test video, the capacitor didn't really blow up, it just puffed up some smoke and that was it. Well, trust me, this thing is really spicy. When you use the correct kind of capacitor, which is a 10 microfarad 16 volt capacitor, it really goes off violently. Like the 350 volts from one side, 6 kilovolts from the other side, it really does go off violently. And trust me, the blow up, how it blows up, it's so loud. It's like a firework. But there's a problem. I've tried to film an English testing video, but I couldn't because all the capacitors I was trying, even the 16 volt ones, were just salvaged capacitors from old stuff because I have been using this alarm clock daily. And I've run out of capacitors, and well, tomorrow it's Monday, so I'm gonna pop down to the nearest electronics parts store to get some more. But I didn't have them, and the ones I salvaged just either got very hot or puffed up a little bit of smoke or didn't blow up at all. There was just no proper explosion, and I've tried it like 20 times. It took so much time to find the correct capacitors to salvage them, and it just didn't work out in the end. So yeah, I'm just telling you this so you know. So yeah, this is pretty much what I'm telling you. So yeah, trust me, it does really blow up, but this is the only kind of good video I could find where it actually does do something to the capacitor. But yeah, all the capacitors I got must have had a bad ESR, or they were open, or they had a bad capacitance, they were gone or stuff like that, because they didn't blow up. Trust me, this thing really blows them up immediately. And the video I filmed was filmed for a friend of mine, and it was in Czech. It was the only kind of proper video. So the voiceover was a direct translation. So yeah, that's it. And let's move on to the end of the video.
Okay, post-editing outro, because I've just started editing the video and I realized that I didn't film an outro, and I've already put the things back onto the bench, so I feel like we should go back to this. So yeah, so again, that's it for this video. I hope you liked it, hope you learned something new, and again, don't ask for instructions, don't ask for the schematics, because I'm trying to play safe. But anyway, that's it for this video, so yeah, bye.